Hi everyone, and thank you for watching this new video. In this demo, I will be talking about Cloudera DataFlow Functions and how to run NiFi flows embedded into AWS Lambda. In this use case specifically, I will be using AWS Lambda to offload a remote SFTP server, get the files and push the files into S3 as soon as the files are made available. Just as a high-level introduction, Cloudera DataFlow Function is a way for you to run NiFi flows as functions within AWS Lambda, Azure Functions, or Google Cloud Functions. So it's really about running NiFi in a completely serverless way so that your NiFi flow is running only when there is something to actually process. So it's a very cost-effective and very efficient way to run NiFi flows for use cases that are, let's say, batch-oriented. So if you have use cases where your flow needs to run every X minutes or once a day, or process files as soon as files are available on the object store, Cloudera DataFlow Function is a perfect fit and will be the most cost-effective way of running NiFi flows. So in this demo, I will be taking the SFTP remote server offloading example, but this approach that I will be describing here can be applied to many other use cases. Like, for example, if you want to incrementally offload a database, the same approach could be used. So in this demo, I will be running two flows. One flow in the first Lambda here is cron driven. I will be running this flow every 5 minutes. In my case, you could choose every hour, every 2 hours, depending on how fast you want your files to be processed. And this Lambda will only be about listing the files available on the remote SFTP server. And we will be only listing the new files that we are finding since the last execution of the Lambda, so that we are only processing new files and we are not taking the files over and over. To do that, NiFi is going to keep a state, and to keep this state across executions, multiple executions of the Lambda, we will be storing the state in DynamoDB. When we are listing files and when we are finding new files that we want to download, we will be sending this information as messages into AWS SQS. And then we have another Lambda, another NiFi flow that will be only triggered when you have messages into the AWS SQS queue. And this Lambda, when triggered, will be retrieving the SQS message and will use this message to access the remote SFTP server, download the file, and push it into AWS S3. Obviously, we could do something more complicated, more complex with some processing on the data. In this case, it's just about offloading. So I'm just taking the files from the remote server and pushing this into S3. You may be wondering why I'm splitting this use case into two Lambdas, because you could do all of this into just one Lambda. This approach is more, let's say, scalable and reliable in case you expect the first Lambda to list tens of files at the same moment. If you have if you expect your remote SFTP server to receive files just a few times a day, well, you could combine the two Lambdas into a single one. But in my case, just because I think this is more efficient, this is more reliable, this is more scalable, and because maybe this Lambda is going to be listing, let's say, 100 files at the same time, I want to split things into two Lambdas, so that if there is an issue with one file, just the Lambda taking care of this file will be failing and you can have additional processing. So that's my way of separating things and making things more scalable. But again, depending on your use case and what you are expecting in terms of volume and number of files and so on, you could have just one Lambda. But I want to show you many options here so that you can understand how Cloudera DataFlow Functions is working and you can apply it to your own use case. So that's really it. That's my use case. and I will go through all of the steps and describing everything that's I put together to implement this use case. So the first step, the first thing I'm going to show you are the two NiFi flows. So for this, I'm going into Cloudera DataFlow Functions, Cloudera Public Clouds and then the Cloudera DataFlow Service. Here you have functions. That's where you can download the binary provided by Cloudera to run your NiFi flows into functions. So you can download the binary for your cloud provider. As I said, we support AWS Lambda, Azure Functions, and Google Cloud Functions. In my case, I downloaded the AWS Lambda binary, and that's something I will be using later. So let me close this. So let's go in the flow designer and let's look at my flows. So the first flow, the one in charge of the listing, is very straightforward. I just have a list SFTP server, list SFTP processor that is just going to list the data available on my remote server. So it's really basic configuration. I have parameterized my processor. So I define parameters that I will be providing when defining my Lambda. So the hostname, port, username, password, and so on. So all of this is parameterized. Then there is a replace text here because the list SFTP processor is going to generate one flow file per file that we are listing. And this flow file will have attributes about the remote files that are available for download. So here in the replace text, I'm just setting the content of the flow file with the full path of the file I want to download from the remote server. And that's all what I'm doing, nothing else. And then I'm sending this as a SQS message. That's it. I have a failure port in case I have trouble sending the message into SQS so that we can retry the full Lambda in case there is an issue. So just to make sure we are not missing files. So that's it. And it's important to keep in mind that we have these failure ports because, as I said, the list SFTP server, the list SFTP processor has a state that is keeping in mind what is the last file we listed so that at the next execution, we are only listing the new files that are made available. And having this failure port, and because we are using NiFi as a function, NiFi stateless, in the end, we will be updating the states in DynamoDB only if there is no failure. So if we are unable to send a message into SQS, we won't be updating the states for this processor, which is really important because we are considering all of this as a single transaction. This is one of the very nice benefit of using stateless. Okay, so that's the flow that I will be running in the first Lambda that is going to be triggered every X minutes. Then, if I look at my second flow, it's a straightforward one as well. So the first thing is here, I'm using an input port. That's where the Cloudera DataFlow function binary and framework that we are providing to you is going to inject the information provided by the trigger that you define with your function. So in this case, we said that we are sending messages into SQS. So this Lambda will be triggered by an SQS trigger. As soon as there is a message landing in my queue, this will trigger my Lambda, and the message, the SQS message, will be injected here in the input port. Then I'm using a log attribute processor. It's just to log all of the information about the message I received. This is to show you how it looks and what we are actually receiving from the trigger. But in production, I will be removing this processor and just going straight to the evaluate JSON path processor. So here, evaluate JSON path is a way for me to extract from the JSON payload that we are going to receive the information I want. I will show you in the logs the JSON payload that we are receiving and why I'm using the evaluate JSON path this way. But you can just look here in terms of configuration. I'm just extracting the path that I set into my other workflow, NiFi flow, and this is this path. So basically, the trigger with SQS is an array of records, but I will be configuring my trigger so that I always receive just one record. And then I will get the body field, which is actually the content of the message I sent, which is the path of the file I'm trying to download from the remote SFTP server. Once I have this, I can do the fetch SFTP, just same parameters as before, but the remote file here, I'm using the attributes that I just extracted before. And then put S3 object just to send my file into the destination I want. So I parameterize the buckets, the directory, and then just using the file name. And that's it. I also use a failure port here in case something is wrong so that I can retry the file in case something is wrong with the remote SFTP server or the S3 sending the data into S3. For the AWS processors that I have here with put SQS and here with put S3 object, I'm using an AWS credential provider. And if we look into it very quickly, here we can see that I didn't give any credential information. I'm just saying use default credentials true. So it will use the role associated to your Lambda to perform the actions to interact with the other services. So it will be just up to you to grant the right permissions to your Lambda so that it can interact with the services. So for my first Lambda, I will give the permission to send messages into SQS. And for the second Lambda, I will be giving permissions to read from SQS and also send data into S3. So that's a way to configure your Lambdas without giving credentials like access key or secret access key or credential files and so on. So it's very convenient to just rely on the role of the Lambda itself. That's it. So those are my two flows. It's really straightforward, but this is what we are going to use to, in real time, well, near real time, offload data from the remote SFTP server. And this is quite powerful because if you look at AWS Lambda and all of the triggers offered by AWS, there is no option to automatically offload remote systems that are not within the AWS scope. So if you have on-prem servers or on-prem databases or on-prem systems overall, you can use this approach to offload systems into AWS or other cloud providers. The same obviously applies to every cloud provider. Okay, that's it. So now let's go to AWS. So let's go to my first Lambda, which is listing. You can see here that I configured it to run every 5 minutes. So you can see here it's running every 5 minutes. And we can see the logs here. So sometime there is a cold start because, well, I don't want to go into the details, but basically AWS Lambda is going to keep around the resources so that you don't have all of the initialization of the code to be done again over and over. AWS is keeping your resources around for exactly 5 minutes. So by running your Lambda every 5 minutes, you are removing every cold start, except sometimes it's not exactly 5 minutes, and you do get a cold start. So for example, here we can see that every 5 minutes is not a very strict thing, and here we can see that it was more like a bit more than 6 minutes. So that's why I had a cold start here, where all of NiFi has to be started again and again. So it took quite some time to load everything for the flow to run, to be initialized, and to do the listing. But if you run things every 5 minutes, you can see that the listing of my remote SFTP server is executed between 1 and 2 seconds. So that's it. I will go into the configuration and show you everything. So first code is you just upload the binary that you downloaded from the Cloudera DataFlow Functions page that I showed you before. You configure the runtime, the handler. All of this is very well documented in the Cloudera documentation. Then you can go straight to the configuration, general configuration, increase, please, the timeout, because as I said, you may have a cold start, which is taking between 1 and 2 minutes. So in this case, you want to increase the timeout to something like 5 minutes. I increased the memory to 1 gig, and that's all I did for this Lambda. In terms of permissions, by default, a role is going to be created, and then you can go into this role and add inline policies based on your needs. So in my case, for this role, I added a few policies, inline policies. There is one allowing the function to store the state into DynamoDB. I added read-only access to my secret. That's where I'm giving the values for my parameters. I will get back to this. I also gave permission with read access to some directory into S3, where I'm giving some NiFi nars to my Lambda. I will get back to this as well. And I also gave the permissions so that my Lambda is able to send messages into the SQS queue I created. So that's what I added in terms of permissions. Then here we have the environment variables. So here we have a few things to discuss about. So first here, access key, private key. So those are credentials that you can create for yourself into the Cloudera public cloud control plane. And this is credentials of the user that the function, the Lambda, is going to use to download the flow from the DataFlow catalog. And you may wonder, what is the Cloudera DataFlow catalog? And I forgot mentioning about this. So let me take a step back. Actually, when your flow is designed and ready to be used, you want to do this. You want to go into the flow options and then publish. This will publish the flow, the definition of your flow into the Cloudera DataFlow catalog. I already did this. So if you go in the catalog, you have, it's kind of a NiFi registry, but a SaaS and completely free version of NiFi registry. So that's really nice to use if you are looking for a completely free of charge way to use a NiFi registry. Reach out to us. There is the Cloudera DataFlow catalog that you can use for free. And this is providing the same features as the NiFi registry. So here I have my 2 flows, listing, ingesting. And when you have your flows, here you have a unique identifier for your flow, the CRN, for the version of your flow. And that's something that we need to reference in the Lambda. So when the Lambda is running, there is the user for which I showed you the credentials. This user is going to be used to access the Cloudera DataFlow catalog, which is Cloudera hosted, and it's going to download the flow definition using this unique identifier. And that's how the Lambda knows what flow has to be running, has to be executed. So let me go back here. So access key, private key, this is just a machine user that I created in the control plane so that my Lambda can access the DataFlow catalog and download this flow definition and run it within NiFi. Then I specified what's the name of my failure output port. I specified a bucket where I added the nars that NiFi is going to require to be running the flow. So if you don't specify this, the Lambda will be downloading the required nars over the internet. But to limit the, let's say, the bandwidth and the access to external internet for my Lambda, I'm already uploading the nars that I require into this bucket and directory. This is something completely optional. You don't have to do it, but this is something I did. And then here I'm saying that the values of my parameters for the parameter context associated to my flow is going to be an AWS secret with this name, DFF SFTP. So that's all of my configuration for this Lambda. And now if I go to here with like in AWS Secrets Manager, I created a secret DFF SFTP, and that's where I'm giving the values of my parameters for my flows. So if we look here, you can see all of my parameters. So S3 bucket, S3 region, SFTP hostname, SFTP port, SFTP username, SFTP password, SQSQ, SFTP, the name of the SQSQ that I created, and the S3 directory where I'm pushing the files. And this secret is where I'm storing the values of my parameters. Then I created an SQS queue, SFTP queue. It's a FIFO one, nothing really important to mention here. That's the queue I'm using to, let's say, have my two lambdas talking to each other. So nothing to say really about this one, but it's just a SQS queue. Then here, this is my bucket. I have a few directories. There is the binary here that I'm using for my Lambda. Here is the destination directory for where I want to push my files. And here is the directory where I pushed the nulls that the Lambda is going to use. Okay, here it's my DynamoDB table that is keeping track of my NiFi state. This is something that is created automatically by the Lambda, assuming you are giving the, let's say, the right permission for the Lambda to create the state, the table state table. But you can also create the table in advance with the appropriate schema here. And this table will be used by the lambdas to store the state. Okay, that's pretty much it. I think that's all that is very interesting here. I published a version, and for this version, I associated a trigger. This trigger is an event bridge rule, and the rule is this. It's rate 5 minutes. So it's a scheduled expression, basically saying run this Lambda every 5 minutes. And that's it. That's all I did here. If we look at the monitoring, so as I said, it's running every 5 minutes. If it's doing it correctly every 5 minutes, you don't have a cold start. Sometimes AWS is not really respecting the 5 minutes. So in this case, you may have a cold start, but this is not really important, to be honest. So you can see here, like every 2 hours, we have a cold start because AWS is not doing it correctly in terms of every 5 minutes. It may be like 6 minutes, 7 minutes, whatever. But in this case, we would have a cold start of your Lambda. Obviously, you can avoid cold start completely by doing a provisioning of your Lambda, saying that you always want one instance running. Obviously, this is more costly because you are asking AWS to keep resources around. So it's up to you. That's it. So here we can go into the logs and we can look at the logs of one execution. So so here we can see the Lambda is being provisioned. First, we are downloading the flow definition from the DataFlow catalog. Then we look into it and we detect the nulls that we need to run this this flow. We download the nulls, we make the nulls available, we unpack the nulls. All of this is being done here. Then we load the flow here. We can see all of the components being loaded and instantiated. All of this is here. And we start the components here. All of the components are started. And here, this is the actual start of the request. So everything before was the initialization of the Lambda, but now it's actually running. So we see here the SFTP processor is running. We are doing a listing. And well, there is no file to list. So we are just returning, like closing the Lambda, and that's it. So here it was a cold start, but you can see the next ones are not cold start. So here you have the full execution here because we kept the resources around. So in this case, the execution is like between 1 and 2 seconds. And that's it. It's always the same. Every 5 minutes, we are running the same code. So that's it. I will switch very quickly to the other one. But before that, let me actually switch to another screen so that we can actually make some data available. So let me switch to the other screen. So yeah, so very quickly, here is an EC2 instance I started on AWS where I'm simulating an SFTP server. And here I created the directory. So actually, let's look into my directory here. So we already have a bunch of data here. I also created very large files, 1 gig per file. But I'm going to remove all of this and create net new files. So here I'm removing everything. And let's just start with 1 file. Okay, so I will just create NiFi test here and just write 1 word into it. Okay, so it's a very small file, but we have like the file has been created here, so it's going to be listed. The next listing should be happening very soon, and we should see the file landing into the S3 bucket. So let me go back to the other screen and let's look into the configuration of the other Lambda. So let's go to this one. So in terms of configuration, this one is slightly different. So I also increased the timeout. Memory is also increased to 1 gig. Here, I changed the ephemeral storage to 10 gigs because I want to support the case where I'm downloading and uploading to S3 very large files. So NiFi will be running this in the content repository, and I want to support very large files. So if you have very large files, you should probably do this. Keep in mind that by default, functions are powered by NiFi stateless, and by default, NiFi stateless is keeping everything into memory. So if you have small files, you can just keep everything in memory, and that's perfectly fine. But in the case where I'm processing a 1 gig file or 5 gigs file, obviously, I don't want to increase the memory associated to the Lambda. So I'm going to increase the ephemeral storage of my Lambda, and I will specify in the configuration of my Lambda that I don't want NiFi stateless to be running completely in memory, but to use this ephemeral storage as the content repository. In terms of permission, same story as before. I gave some inline policies allowing this Lambda to do the proper things, like receiving SQS messages, read-only access to the secret, and the access to AWS S3. In terms of environment variables, so I specified here that the content repository should be /tmp, which is where we are, where the ephemeral storage of the Lambda is mounted. So I'm saying, don't use memory for the repositories of NiFi. Please use content repository. Set content repository to the ephemeral storage and use this. Otherwise, everything else is same as before, except that here the flow CRN is going to my other flow definition. So it's the ingesting flow that I showed you before. And that's it. No, something that I did specify for my function is specify here reserved concurrency 1. The reason I did this is because I want the concurrency of this Lambda to be at most 1. I don't want multiple instances of the same Lambda to be running. The reason is I don't, like, if I'm listing 20 files in one execution, I don't want 20 Lambdas to be executed for downloading and uploading into S3. I prefer to have the same one taking care of the 20 files one after the other, so that I don't have 20 cold starts. Because if I'm running 20 Lambdas at the same time for my 20 files that I just listed, it will be 20 instances, and every instance will be doing a cold start. So it's up to you. Again, depends on your use case. But in my case, I'm assuming that I'm not receiving a lot of files. So it's very likely that the ingest Lambda will have a cold start when it's cold. So that's why I'm setting the concurrency to at maximum 1. But it's up to you. It depends on the use case, what makes sense for you. If you are always receiving files and you want files to be processed as quickly as possible, then you may want to just keep the default, and the Lambda will be triggered concurrently based on the number of messages you will be receiving through SQS. So really up to you. That's it. I published a version, and in this version here, I specified a trigger, which is my SQS queue here. So basically, anytime there is a message landing into SQS, please trigger my Lambda. And here, something that is important here, I'm saying batch size 1. So that's what I was mentioning before in my flow definition. I know that I will be receiving just one record, because here I'm setting the batch size to 1. So one execution of the Lambda will be taking care of one file, and just one during one execution. That's, again, because I want to make sure that if there is an issue with one file, I'm not making the full Lambda execution to fail, but just a failure for one single file. So that's my approach. Again, this is something you could do differently if you want. Okay, then I can look into the monitoring, and hopefully we have an execution for the file I uploaded just before. And that's what we see here. So we see there is a cold start here, and we can go into the logs and see what happened. So here, same story as before. We have the init start, so it's the initialization of NiFi within the Lambda. So we are downloading the flow definition, loading everything. So unpacking the nulls, loading the flow, starting the flow, and so on. So I'm switching all of this. I'm skipping all of this, sorry. And here is the actual beginning of the execution. I received the trigger from SQS, and here I have the execution of my log attribute processor, where we can see what is the flow file that the system has injected into my flow definition. Through the input port, if you remember. So let me show you here. It's here in the input port. The framework of Cloudera DataFlow function is taking the information that AWS is giving us with the trigger, and it's injecting this information as a flow file here. That's what we see in the logs here. So we have a bunch of flow file attributes. So it's not really important. We don't really care here. And here we have the content of the flow file. And here, we can see this is the content of the flow file. This is specific to the SQS trigger. If you are using another type of triggers, the content will be different. But here, this is my SQS trigger. As I said, it's an array of records. I specified that I always want one. And here, for each record, there is a field body, which is containing the path of my file. So if you remember, that's what I created here with the replace text. Here I said, please give the content of my flow file the full path of the file, and then send this as my SQS message. Okay, so here what we see is body of my SQS message contains the path to the file I created before on my remote SFTP server. Once we have this, we get the file. Here there is a lot of logs for put S3 object. This is because the processor is looking into multi-part uploads done in the past, but it's not really important. We upload the things successfully into the bucket, and the execution is completed here. If I go into my bucket here and look into my SFTP and refresh, I received my file test here on the date of the execution of my Lambda. So we received everything as expected. This is working nicely. If we look at the metrics, everything is looking good. Okay. Okay, so I switch back to the console, and now I'm going to create a bunch of files. And I'm also going to create a very large file, like 5 gigs, just to show you what happens in case you have a large file, and also what happens if you have many files landing at the same time. So let me do this. I'm going to create a lot of small files. Let's do this. So I'm creating a lot of files, and then I'm going to create a very large file, let's say 5 gigs here. Okay, 5 gigs is too much. So let's say 3 gigs. And another one of 1 gig. I think it should be okay. I created a default EC2, so it's probably not a lot of space. Well, okay, it's fine. Just one with 3 gigs and a bunch of files. Okay, so now let me switch back to the AWS control plane. Okay, so now here, if I look into my listing, the last listing was at 1 p.m. 01, and it's 1 p.m. 03. So we have to wait a few seconds here. And here I will go into the monitoring and logs here, just to show you what happens here when we have multiple files to download. Okay, so I'm going to pause the recording because the next listing will happen in a few minutes. So let me pause the recording and get back to you when the listing has been executed. Okay, so we are back. It's now the listing should be happening right now. So let me refresh here. We still have 1 p.m. 01. So now the new listing should be happening any minute now. So I'm going to refresh here a couple of times, and hopefully we can see the logs where we are listing I created how many files? 5 small files and 1 3 gigs file. So let me refresh. So it takes some time for AWS to make the logs available after the execution of the Lambda. But yeah, hopefully it's going to be showing here very soon. And so because I set the concurrency to 1 on my ingesting Lambda, we should see many executions of the Lambda on the ingesting side. So here it's the listing side. It's being executed every 5 minutes, and I'm just, well, hopefully it's using the same log stream. So let's go directly into the log stream, and hopefully, yes, we can see here the listing here. Yeah, so here the timing is GMT, and here it's GMT +2 because I don't know, exactly why, because the Lambda is running in London. So it's not really making sense. But anyway, that's the new execution. So so we can see here we have 7 replace text here. So I created 7 files, and we have the 7 messages sent into SQS. Okay, so here we have all of the messages. And then here on the downloading side, so it's going to take a few seconds to get here, but so we successfully send the messages into SQS. Actually, if I go here and I look into the monitoring, hopefully we can see here that messages have been received. So here we have the messages. So this is what is going to trigger my Lambda for ingestion. And here we should see the execution. So the first one is going to be a cold start because the last download was about 12-13 minutes ago, even a bit more. So the first one is going to be a cold start, but we are going to download the files one by one. I mean, we are not provisioning the Lambdas with concurrency because I set concurrency to 1. So the first download is going to be a cold start, but then the consecutive downloads are going to reuse the same Lambda instance, so it will be very fast for the next ones. So actually, the overall we can see here. So cold start for the first file that we are downloading and pushing into S3, but then the subsequent executions, you can see it's extremely fast. It's below 1 second to download and upload the file. So it's very, very efficient here. So I'm going to refresh here. There is probably, here we are probably, so right now it's probably the 3 gigs file that is being processed right now. So that's probably why. So here we can see small file, but with a cold start, so it's taking about 1 minute, 20 seconds. Then we have 4 additional files where it's taking below 1 second to download from the remote SFTP server and push into S3. And I'm waiting for the logs related to the big file. So hopefully we should see it soon. So while we are here, I will just refresh also here in my bucket. So we have all of the small files, and I imagine that right now the upload of the large file is ongoing. So we should be seeing the file here soon. So I don't know how long it takes to upload a 3 gigs file in here, but I don't know, should be taking maybe 30 seconds, something like this. I have no idea how long it takes, to be honest. So let's refresh here. Let's check the logs here. So it's probably still happening. When I was doing the 1 gig file, it was taking about 20 seconds to do the download from the remote SFTP server and the upload into S3. So here it's probably taking a bit more. So here it is. So here, actually, this is the 5 gig file. So I guess my comment for fallocate, even if there is no space left on device, was actually creating the file. So okay, that's interesting. Anyway, it's okay. So it's actually a 5 gig file that we uploaded, and we have here the one that I tried to create with 1 gig that failed because there was no space left on device. It's fine. That's why we have our 7 files. The comments on my remote SFTP server was actually creating the file, but not with the expected size because of the limited space on the device. Anyway, we uploaded everything successfully. And if I go back here and we check the logs, we should see additional invocations here. So I just want to wait for all of the invocations, because as you can see here, we have the same log stream for all of the invocations. So AWS will be reusing the log stream across the invocations if this is the same instance of the Lambda. I'm just going to wait a bit more, but otherwise I will just go in the log stream and show you what we see there. Okay, well, let's go in the log stream. Hopefully it will be loading everything quickly. So same as before, this is the initialization of the Lambda instance. I will skip everything. This is starting, and here is the first request. So the first actual invocation with the first file. So if we look here, so here we are taking care of my file test2. This is downloading, same as before. There's a bunch of S3 objects, put S3 object invocation, because we are looking at multi-part upload in my bucket, and I have a bunch of files for other reasons where there is a multi-part upload to a board. So that's why we see a lot of logs here, but this is unrelated to what I'm doing here. It's because I have a lot of files in my bucket. Anyway, here, this is saying that we successfully triggered, and then we switch to the next file coming from SQS. So here we can see this is my file test1, and then we go to the next file. Here it's my file test3, and so on. So we can see file by file that we are doing the execution. And if I keep scrolling down, this is all of my files one by one. And here, for example, here, this is my test GB. So the file that was actually empty. But if I look before, I think this is the interesting one. So for example, here, this is the start of the invocation taking care of the 5 gigs file. It's starting at 3 p.m. 08/23. So log attributes, and then here is the download. So the download took about, let's say, 4 minutes. Download and upload took about 4 minutes. So we downloaded the file and pushed into S3, and it was about 4 minutes. So actually, if we go over, like, we need to process files that are even more than 5 gigs, we probably need to extend the timeout of the Lambda even more. Okay, so if I go back here and refresh, this time we should see all of the invocations. So that's it. So here it was 1 minute 20 seconds because it was a cold start. Then we had a lot of invocations, but it was not a cold start because we can see it's the same log stream. So we were reusing the same instance of the Lambda. For the small file, very efficient download upload. But for the 5 gigs file, it took about 4 minutes. Almost 5 minutes. So in this case, if we need to take care of files larger than 5 gigs, we will need to increase the timeout of the Lambda. That's it. Just a recap of what I've been showing in this demo. So how to use Cloudera DataFlow Functions and design flow definitions with NiFi in the Cloudera DataFlow Designer, so that you can have NiFi flows running in Lambda to offload in near real time an SFTP server, remote SFTP server into AWS S3. That's how I did it. I used the first flow definition that is just listing the files available on the remote SFTP server. I'm storing the states in DynamoDB just to make sure that at every execution of the Lambda, I'm only looking for new files that we want to list since the last execution. For every new file, I'm sending a message into SQS. This message is configured as the trigger of the next Lambda. This Lambda is in charge of fetching the file from the remote SFTP server and pushing the data into S3. That's it. Cloudera DataFlow function is available to run flows as functions in AWS, Azure, and Google Cloud. If this is something of interest for you, please reach out. I'm happy to answer any question. I designed my flows using the nice and very cool Cloudera DataFlow Designer, which is available with Cloudera DataFlow, but you could design your flow for functions using the traditional Apache NiFi UI if you want. So it's not an obligation to be using the Cloudera DataFlow Designer to design flows to be running as functions. But in this case, it's quite nice. This UI is looking nice. So I use this UI to design my flows. That's it. I hope you enjoyed it. Again, this is a very simple use case, but this approach can be used for many different use cases. And functions are really, really powerful if you want to cost optimize as much as possible flows, NiFi flows that do not need to run 24/7. So it's a serverless approach for running NiFi flows, and NiFi is running only when there is something to do. So it's very cost effective. I hope you enjoyed it. Thanks for watching. As usual, feel free to post comments, ask questions. I will do my best to answer as soon as possible. Thanks again, and see you in the next video.